Hello students, today's class we will discuss about the upper confidence bound algorithm in reinforcement learning. So upper confidence bound algorithm is a deterministic algorithm for reinforcement learning that focuses on exploitation based on a confidence boundary. So we know that in reinforcement learning, initially we'll explore. Okay, so the agent will explore. Okay, it will try n number of options. Okay, and then at one point, okay, so at one point, maybe at random, it will finalize that this will be a best option, and then it will start to exploit. Okay, so now the upper confidence bound is one that concentrate on this part of the reinforcement learning. Okay, so whenever there are many options to explore, so which will be the best option to proceed towards exploitation? Okay, so suppose I just try this exploration, and I should not keep on trying this particular arm for exploration. So I have to explore n number of other samples as well. So the upper confidence bound says how much time you can try a solution for exploration. Okay, so it talks about how much time you can try for exploration. All right. So that is what is the upper confidence bound talk about. And the upper confidence bound also is it says that it decreases. Okay, it decreases the level of a machine. Okay, the reward of a machine whenever it is tried many times. Okay, when you feel that, so for example, you imagine that there are machine 1, 2, 3, and 4. You keep on trying one, you may not be exploring 2, 3, 4, which may be a better solution than one. So obviously you have to try 2, you have to try 3, and you have to try 4. So if suppose you're trying one for many times, it will decrease. The upper confidence bound will decrease the score so that you switch to the other options and try that. So this is an explanation for upper confidence bound. It focuses on the exploration and exploitation. It is based on a confidence boundary. Now let us look at the equation for the upper confidence bound. Okay. So the upper confidence bound equation is nothing but the maximum of, okay, the maximum of Qt of A. So Qt of A is nothing but the score that we receive through the, maybe we have discussed many techniques, epsilon greedy technique, sample averaging technique, incremental updates, and everything we explored this Qt of A. In addition to that, we have added one component to it, which is nothing but C. C is a constant, and T is the time at which I'm making this move. Okay, time at which I'm making this move, and NT is number of times I have made this move. Okay, number of times I have tried it. So, and among that, which is the maximum, I'll take that. From there, I will proceed towards the greedy approach or the exploitation approach. Okay, so this is the equation for upper confidence. So now let us look at an example. So now initially D1, D2, D3, D4, D5 are the different machines. And imagine that these are the distributions that they follow. Okay, so these are the rewards that they have initially. All right. And this y-axis is the reward. All right. So now you see that these are the rewards initially it has, and but a user does not know what is the reward that it has. Okay, or the agent, I should say the agent. The agent does not know what reward it has. So the agent will imagine that everybody are having the same reward and say it picks up 1. In random, it picks up 1. So now when it picks up 1, okay, what the UCB algorithm will do is, it will calculate the upper bound and the lower bound. Okay, it will calculate the upper bound and the lower bound. And this is the assumed distribution. So now as 1 is picked, okay, as 1 is picked based on the formula Qt of A plus C root of 2 ln n divided by n of j, okay, using this formula, this, when I accumulate the reward, okay, I just take the reward plus this term, I'm adding this term. the bound get decreased. Okay, the bound get decreased. So from this, what the agent will try to know is the score is decreased. So let me try out some other machine as well. So now it will try out 2. So now as 2 is tried, again, it bound may decrease. So whichever is tried so many times, it will have a less bound. All right. It will have the reward will increase. If suppose it is having a positive reward, the reward will increase, but the bound will get reduced. All right. So after so many runs, it is understood that this has this reward. Okay, this machine, right? This machine is having a highest reward. Okay, and for that reward, when the bound is calculated, this is the bound. Okay, now it is assumed that this will be the best option, and from here it will start its exploitation. Okay, so this is how the upper confidence bound. It started with exploring all the mission, and which has the highest confidence bound. Okay, so it will start explore, thereby finding the best mission after some exploration, and then started reaping the benefits of maximizing the profits. So this is a crush of the upper confidence bound algorithm. Crust of the upper confidence bound algorithm. That is, it will find, initially it will assume everybody is equal. It will calculate the upper confidence bound. So as the reward increases, new bound is calculated for the reward at time t. Now, after certain run, it is understood that this is having the highest reward in the exploration phase. And then this will be taken for the further actions.